Introduction. All matter is composed of basic elements that cannot be broken down to substances with different chemical or physical properties. Elements are substances consisting of one type of atom. For example, carbon atoms make up diamond and also graphite. Pure 24-karat gold is composed of only one type of atom, gold atoms. Molecules are compounds in which the elements are in definite fixed ratios. For example, water, glucose, ATP. Objectives. At the end of this lesson, you'll be able to know about laws of chemical combination like law of conservation of mass and law of constant proportion. Discuss Dalton's atomic theory and understand about atoms, molecules and more. Laws of chemical combination. Chemistry deals with the matter and the changes occurring in it. Chemists are particularly interested in these changes where one or more substances are changed into quite different substances. They had found that these chemical changes are governed by some empirical laws known as laws of chemical combinations. These laws are law of conservation of mass, law of constant composition or law of definite proportion. Law of conservation of mass. According to this law, matter cannot be created nor destroyed in chemical and common physical changes. For example, zinc reacts with sulfur molecules to form molecules of zinc sulfide. Law of constant proportions. The law of constant proportions, which is also known as the law of definite proportions. This law was stated by Proust. As in a chemical substance, the elements are always present in definite proportions by mass. In formation of water compound, the ratio of the mass of hydrogen to the mass of oxygen is always 1:8, whatever the source of water. Thus, if 9 grams of water is decomposed, 1 gram of hydrogen and 8 grams of oxygen are always obtained. Dalton's atomic theory. Dalton's atomic theory provided an explanation for the law of conservation of mass and the law of definite proportions. The postulates of this theory are: 1. All matter is made of very tiny particles called atoms. 2. Atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. 3. Atoms of a given element are identical in mass and chemical properties. 4. Atoms of different elements have different masses and chemical properties. 5. Atoms combine in the ratio of small whole numbers to form compounds. 6. The relative number and kinds of atoms are constant in a given compound. Atoms. Our entire world is made up of atoms. We may not be able to see them, but they are there and constantly affecting whatever we do. Atoms are very small. They're smaller than anything that we can imagine or compare with. More than millions of atoms, when stacked, would make a layer barely as thick as this sheet of paper. Through modern techniques, we can now produce magnified images of surfaces of elements showing atoms. Example: silicon surface showing atoms. Symbols of atoms of different elements. Dalton was the first scientist to use the symbols for elements in a very specific sense. When he used a symbol for an element, he also meant a definite quantity of that element, that is, one atom of that element. Berzelius suggested that the symbols of elements be made from 1 or 2 letters of the name of that element. Symbols of some elements are formed from the first letter of the name and a letter appearing later in the name. Each element has a name and a unique chemical symbol. For example, argon, Ar, chlorine, Cl, zinc, Zn, etc. Molecule. A molecule can be defined as the smallest particle of an element or a compound that is capable of an independent existence and shows all the properties of that substance. Molecules of many elements such as argon, Ar, helium, etc. are made up of only one atom of that element. 2. A molecule of oxygen consists of two atoms of oxygen and hence it is known as a diatomic molecule, O2. If three atoms of oxygen unite into a molecule instead of the usual two, we get ozone. Atomicity of elements. The number of atoms constituting a molecule is known as its atomicity. Let us look at the atomicity of some elements. Molecules of compounds. Atoms of different elements join together in definite proportions to form molecules of compounds. For example, water, ammonia, carbon dioxide, hydrogen peroxide, etc. Did you know? The concepts of both matter and mass conservation is widely used in many fields such as chemistry, mechanics, and fluid dynamics. Historically, the principle of mass conservation, discovered by Antoine Lavoisier in the late 18th century, was of crucial importance in changing alchemy into the modern natural science of chemistry. Steel is harder than iron because its atoms are bound together in a more rigid crystalline lattice. Wood burns or undergoes rapid oxidation because it can react spontaneously with oxygen in a chemical reaction above a certain temperature. Sugar and salt dissolve in water because their molecular ionic properties are such that dissolution is preferred under the ambient conditions. Summary. Let us summarize what we have learned. During a chemical reaction, the sum of the masses of the reactants and products remains unchanged. This is known as the law of conservation of mass. In a pure chemical compound, elements are always present in a definite proportion by mass. This is known as the law of definite proportions. An atom is the smallest particle of the element that can exist independently and retain all its chemical properties. A molecule is the smallest particle of an element or a compound capable of independent existence under ordinary conditions. Introduction. A chemical formula or molecular formula is a way of expressing information about the atoms that constitute a particular chemical compound. Chemical formulas may be used in chemical equations to describe chemical reactions. For ionic compounds and other non-molecular substances, an empirical formula may be used in which the subscripts indicate the ratio of the elements. Objectives. At the end of this lesson, you'll be able to understand ions of different compounds, calculate molecular mass, and write molecular formula of different compounds. Ion. An ion is a charged particle and can be negatively or positively charged. A negatively charged ion is called an anion, and the positively charged ion is called a cation. For example, sodium chloride. Sodium chloride, its constituent particles are positively charged sodium ions and negatively charged chloride ions. A group of atoms carrying a charge is known as polyatomic ion. Example, nitrate ion. Writing chemical formula. The chemical formula of a compound is a symbolic representation of its composition. For this, we need to learn the symbols and combining capacity of the elements. The combining power or capacity of an element is known as its valency. Valency can be used to find out how the atoms of an element will combine with the atoms of another element to form a chemical compound. The valencies of some simple and polyatomic ions are given in table. The rules that you have to follow while writing a chemical formula are as follows. The valencies or charges on the ion must balance. When a compound consists of a metal and a non-metal, the name or symbol of the metal is written first. For example, calcium oxide CaO, sodium chloride NaCl, iron sulfide FeS, copper oxide CuO, etc., where oxygen, chlorine, sulfur are non-metals and are written on the right, whereas calcium, sodium, iron and copper are metals and are written on the left. In compounds formed with polyatomic ions, the ion is enclosed in a bracket before writing the number to indicate the ratio. Formula of simple compounds. The simplest compounds, which are made up of two different elements, are called binary compounds. While writing the chemical formula for compounds, we write the constituent elements and their valencies. Example: hydrogen chloride HCl, hydrogen sulfide H2S, carbon tetrachloride CCl4, aluminium oxide Al2O3. Molecular mass and mole concept. The molecular mass of a substance is the sum of the atomic masses of all the atoms in a molecule of the substance. It is therefore the relative mass of a molecule is expressed in atomic mass units. Example: the molecular mass of HNO3 is equal to the atomic mass of H plus the atomic mass of N plus 3 into the atomic mass of O, which is equal to 1 plus 14 plus 48, which equals 63 units. The formula unit mass of a substance is a sum of the atomic masses of all atoms in a formula unit of a compound. Example: formula unit NaCl. Its formula unit mass can be calculated as 1 into 23 plus 1 into 35.5, which equals 58.5 units. The number of particles, atoms, molecules, or ions present in 1 mole of any substance is fixed with a value of 6.022 into 10 raised to the power 23. This is an experimentally obtained value. This number is called Avogadro constant or Avogadro number, represented by N0, named in honor of the Italian scientist Amedeo Avogadro. 1 mole of anything is equal to 6.022 into 10 raised to the power 23. Did you know? A compound's empirical formula is the simplest integer ratio of the chemical elements that constitute it. For example, water is always composed of a 2:1 ratio of hydrogen to oxygen atoms, and ethyl alcohol or ethanol is always composed of carbon, hydrogen, and oxygen in a 2:6:1 ratio. However, this does not determine the kind of molecule uniquely. Dimethyl ether has the same ratio as ethanol, for instance. Molecules with the same atoms in different arrangements are called isomers. The molecular formula reflects the exact number of atoms that compose the molecule and so characterizes different molecules. However, different isomers can have the same atomic composition while being different molecules. The empirical formula is often the same as the molecular formula, but not always. For example, the molecule acetylene has molecular formula C2H2, but the simplest integer ratio of elements is CH. Summary. Let us summarize what we have learned. A chemical formula of a compound shows its constituent elements and the number of atoms of each combining element. Clusters of atoms that act as an ion are called polyatomic ions. The chemical formula of a molecular compound is determined by the valency of each element. Scientists use the relative atomic mass scale to compare the masses of different atoms of elements. Atoms of carbon-12 isotopes are assigned a relative atomic mass of 12, and the relative masses of all other atoms are obtained by comparison with the mass of a carbon-12 atom. The Avogadro constant, 6.022 into 10 raised to the power 23, is defined as the number of atoms in exactly 12 gram of carbon-12. Mass of 1 mole of a substance is called its molar mass.